Good morning, guys. Your friend Jim here with another video. Welcome back to the channel, the 2004 Mitsubishi Montero channel. If you are new here, please go ahead and subscribe, like this video, and also hit the notification bell so you can get notified when I upload a video. I don't upload videos very often, but when I do, I try to make them good quality and really informative. So, well, I don't know about quality, but at least informative. So today we're going to be talking about my 04 Montero, of course, and we're going to be talking about no start conditions. Imagine you go and you try to start your vehicle and boom, you have a no start, or you have a start and stall. We're going to go over 3 scenarios where this may happen to you, and I'll show you the cause, the way to diagnose it, and the things to check. So scenario number 1, we're going to start with the easy one. When your key, where's the key? It's right here. When your key loses, inside this key there's a transponder, and it has a tiny battery. It lasts about 10 to 15 years, and after it has no more power, then it will not transmit the signal to start the engine. So it'll start in 1 second and then it'll stall. I'll show you what that looks like in a few minutes. The other scenario that I wanted to talk about is the fuel pump. Let's say, for example, your fuel pump is not working. Here's a circuit diagram, and I'll show you all the items here. Start the vehicle, crank, no start, but you don't know if it's because it has no spark. You don't know if it's because it has no fuel. You're not 100% sure. So I'll show you how to go about that and check out the different items on the vehicle related to the fuel pump circuit. And then the third scenario is crank, no start, no spark situation. And the scenario I'm going to do is a scenario where you have no crank sensor signal to the computer. No crank sensor signal, the computer doesn't know what's going on. It won't trigger the coils, so you'll have a no spark condition. Also, it won't trigger the injectors, so also no fuel condition. Though no start due to no fuel, no start due to no spark, it's very similar. You're cranking the engine at normal cranking speed, but it's not starting. Another situation where you have a crank no start condition that you can sort of tell what might be going on is if you have no compression. If you have no compression, then it's going to be much easier for the starter to turn the crankshaft, so the cranking speed is going to be much higher. Speed is going to be much faster than cranking speed when you have compression. So I can't demonstrate that today because I don't have the spark plugs out, but next time I have the spark plugs out, I can go ahead and show you. But it's common sense. You get the idea. So yeah, those 3 scenarios we're going to go over real quick right now. It shouldn't be a very long video, but I think it's going to be very informative. So just stay tuned, grab a cold beverage, and enjoy the video. Alright guys, there's the Montero right there. And so I'm going to go ahead and show you the situation where what the symptom looks like when you have a transponder that's not working properly. Now if you look at the key ring here, you see how it's got this little copper, it's basically an antenna. That's a copper antenna. So when you turn the key to the start position, it'll send the signal through this antenna to the ECU. I believe it's the immobilizer ECU, and it'll say, okay, that's the right code, or nope, that's not the right code, or nope, we don't have a code at all. So this would be a normal functioning transponder. This is the key. You go ahead and put it in here, and as you can see, it starts, stays running, everything is normal. Okay, turn the AC off. Alright, so I'm gonna shut it down, and this other key is a bad one. This one is probably the original one that came with the vehicle, and almost 20-year-old vehicle, this key does not work anymore. And this is the way it acts when your key doesn't work anymore. Try it again. See how it starts and stalls? See, and it does that because there's no signal coming out of this guy. So the immobilizer ECU says, hey, wait a minute, that's not the right code, or there is no code. I'm shutting the engine off. And that is how it functions when your key transponder either has the wrong code or does not have a code at all. Starts and it stalls. Okay, so that's a simple one. Let's go to the next one. All right, so here we are, basically scenario number 2. So you have your Montero and you crank it over and it does not start. What do you do? Okay, no start condition on a Montero could be a little bit scary because you don't know what the hell is going on. But anyway, this is what it sounds like. I'm sure you're all familiar with the no crank no start condition, but here it goes. So it's almost acting like it wants to start. Maybe it's got a little bit of residual fuel in there. And as you notice, the RPMs did pick up a little bit because it did have a little bit of residual fuel in there. And that's actually a very good clue, because that is letting you know that if it had a little more fuel, then it would start. And it's also letting you know that the computer is receiving an RPM input from the crank sensor, because as it got a little momentum, you saw that needle go up a little bit. That indicates that it does have a crank sensor signal going into the computer. So, but we only got that clue because we had a little bit of residual fuel in there. But let me just keep on cranking it to eliminate all that. See, here's a no crank, no residual fuel, not even trying anything, so that gauge doesn't move at all. So if this is a scenario, then you have no idea if there's a crank sensor input or not. We got lucky because we had a little bit of fuel left over in there. But let's say, for example, you don't know. You crank it over, no start, the needle's not moving. You don't know if it's not starting because of a lack of fuel. You don't know if it's not starting because of a lack of spark. You know, you're not sure. Cranking speed wise, it sounds pretty normal, but so you know that it's probably has compression, otherwise the RPMs would be a lot faster. So with the no start condition, one of the things you need to do when you diagnose this situation is you have to divide and conquer. The engine only needs so many things to start. You know, it needs fuel, it needs spark, it needs timing, it needs mechanical, like good compression, the engine to be mechanically okay. It needs exhaust, and they should start. Of course, it's got to be good quality fuel. If you have contaminated fuel, that's another scenario there. So in this case, let's see which you need to know which direction you're going to take. Why isn't this thing starting, right? So is it because of lack of fuel? Does it not have a crank sensor input? What is it? One quick thing you can do is spray some throttle body cleaner into the throttle body and then see if it helps it, see if it likes it a little bit. It's not going to start and run and nothing like that, but at least you'll know that it'll grab on and catch, and maybe you'll read some RPM. So let's give that a shot. So throttle body. Okay, so we get our spray, this stuff right here, this carburetor spray, throttle body cleaner, whatever, and we just spray a little bit like that, and not too much, because see how it's just sitting right there, so it's going to be sucked in once I crank the engine. And if it tries to start, then we know that the engine wants fuel. That means that it's not starting because of a lack of fuel. So let's see here. There we go. See how it started and then it stalled? Because it burned that little bit of carburetor spray inside. It started the engine and then it just ran out and it just shut off again. So now we know. Now we know that we're not going to worry about the spark. We're not going to worry about anything else. We know that it's a lack of fuel, the reason why this engine is not starting. Okay, so let's move on to the circuit and see what's going on with the circuit. All right, and what I mean by circuit is the fuel pump circuit, to see if the fuel pump's getting power. All right, guys, so just to go over the circuit here, the fuel pump relay circuit. As you can see, It starts from fuse number 6. That's the fuel pump fuse, and then this fuse provides power to terminal number 3 of fuel pump relay number 1, which is this guy here, terminal number 3. And then once the relay closes, the computer activates the relay. Then fuel pump relay number 1 sends power out to fuel pump relay number 2. Both relays get key on power on terminal number 4. Here's terminal number 4 of relay 1, terminal number 4 of relay 2, and that comes from the ignition switch, as you can see right there. So as soon as you turn the ignition switch on, relay number 2 gets power. Terminal number 2 right here is grounded all the time, so this, as soon as you turn the key on, this relay is activated, and it gets power right here from relay number 1. When you turn the key on, the computer does not ground, does not trigger relay number 1. You have to crank the engine for the computer to do that. It's not like some of the other vehicles where the computer triggers this relay for a couple seconds upon turning the key on to prime the system. This Mitsubishi Montero does not work that way. You have to crank it, and then the computer grounds this guy to basically terminal number 2 of relay number 1 to activate relay number 1. Once relay number 1 is activated by the computer grounding terminal number 2, the relay number 1 sends power out on terminal number 1 to terminal number 1 of relay number 2. And by this point, relay number 2 should also be activated, so this switch is closed, and then that's when the fuel pump, this terminal number 3 of relay number 2, sends power out to the pump. And here's the pump, and then it goes to ground number 15 right here. Now, this diagram, this information, we have the connector layout for the relays. B19X is relay number 1, B24X is relay number 2, and they show a little diagram of what terminal number 1, 2, 3, and 4 are. But as I mentioned right now, you have to look at it as if you were looking at it from the bottom, or if you were to get the relay, turn it over, and then look at it. So this is, I'll explain to you exactly what I'm talking about. So basically, this is what it says on the diagram. This is how the terminals are. So 1, 2, 3, 4, but don't look at it that way. When you go to the car, this will be terminal number 3, and so basically you have to look at it as if it was 180 degrees flipped. So we flipped 180, so now this is the way it actually is when you're checking voltage here on the terminals. 3, so it's 1, 2, 3, 4, and so this is the terminal on relay number 1 that gets power from fuse number 6. This is key on power, and then this is the one the computer grounds to trigger relay number 1, and this is the output of relay number 1. So it's a little tiny bit different on relay number 2, but that's not too much of a big deal. Basically, relay number 2, just so you know, terminal number 4 is key on power. Sorry. So terminal number 4 is key on power. Terminal number 1 is power from relay number 1. Terminal number 3 is output to the pump, and then terminal number 2 is basically always grounded. So let's go to the car and do an actual check on these terminals. Okay, and as far as relay location, if you go to the fuel pump, if you go to the under the hood on the relay box, fuse box, you'll see fuel pump relay number 1 right here, fuel pump relay number 2 right there. Let me show you all this stuff on the vehicle, and we'll do some voltage tests on some of the circuits here. All right guys, so let's go here to the Montero, and we need to see if the fuel pump is getting power. So let's we already went over the circuit a little bit. Now let's see where these components are located on the vehicle itself. Now we have the relay box right here. There's a relay, there's an ECU, and some more, there's a fuses, ECU, and some more relays up here. But the fuel pump relays are under this little box. We take that off, and then we also take this one off. and then I'm just gonna move them to the side over here, just so they can be out of the way. And I'll show you here on the vehicle. So I already checked the layout for the relay, the fuses, and this one here would be the fuel pump fuse. This guy right here at the corner. It's a 20 amp fuse, and then I also have this little tool. This little tool is usually on the inside interior fuse box, and there's a little place where you can put this little tool. I just keep it right here, and then it's got basically it's like little crimpers. You put your fuse in there. You put it on your fuse like that, and then it's easy to pull out like that, and also to install there. Alright guys, so my battery ran out on the GoPro, so I had to get another one. So anyways, I was saying, that's the fuel pump fuse right there, as I mentioned, and then these are the fuel pump relays, relay number 1 and relay number 2. So these are just standard relays, 4 terminals, 2 terminals for the coil and 2 terminals for the switch. That's basically all they are, and I believe they're interchangeable. But as you saw on the circuit, the power from this fuse goes to one of the terminals here. I believe it's terminal 3 according to the wiring diagram. So I'll show you which one is terminal number 3. So let me remove this relay. It's not that easy to remove because it's got like a little locking mechanism on this side and the same thing on this side. So you have to get one loose. While holding that one loose, use a little pin or something to get this one loose, and then the whole thing comes out. And same thing with this. So let me give that a shot here real quick. So see, that's got these little locking tabs right here. Okay. Now, okay guys, I got both relays out right here, and it's tricky because it's the same part number, both relays. But when you pull fuel pump relay number 1, you grab it like this, and then you pull on it this way, the flat side like this, not this side, like this, as you're prying the little tabs open, and then you're pulling it out. But fuel pump relay number 2, there's no room to grab it that way because there's this other relay right here. So you have to grab it on the sides like this. So you pull it out this way. As you're pulling it, you move the tabs. The problem with that is this little black cover has the locking tabs on this side and also on this side. So if you grab it this way and pull it out, that's gonna make the little locking tabs loose. So you run the risk of removing this little cover and exposing the mechanism, which is really not a big deal. I mean, it's just a relay circuit in there. You can see the switch right here, and obviously the coil. What I did is that happened to me just now, and instead of putting this back, I just grabbed it from here gently as I pried these guys open, and then now I'm just gonna put this thing back, and that's it. It didn't hurt anything. It's just the way you grab it, and it just happens that way. So when if that happens to you, don't be alarmed. Just snap it back on there, and that's it. So now we're going to talk about how these terminals are laid out here. So as you can see, you have the terminals for relay number 1. We have the terminals laid out here, and then for relay number 2 right here we have the 4 terminals. So I'll show you which one's the terminal number 3 here. So so here's our fuse. We have power on our fuse. See, the light comes on. So fuel pump fuse feeds power to terminal number 3 of the relay. So one of these of relay number 1. So one of these 4 terminals will have power. So this one, I'll show you here. So that's the one that has power. None of these other ones have power. So this one here is terminal number 3, because according to the diagram, the fuse, which has power all the time, even with the key off, sends power to terminal number 3 of the relay, which is this guy here. Alright guys, one more thing about these relays is if you look really carefully inside here, these terminals are actually, they're labeled. Two of these terminals, like for example, these two, if you look really closely inside here, these two say coil. Okay, so obviously these are connected to the coil. These two, they're labeled, but they say NO. What does NO mean? NO means that it's normally open. So these two are connected to the switch, a switch that is normally open. The switch closes when the coil gets magnetized. We all know how a relay works. Alright guys, let's just go over to the circuit here real quick. I do have my test light here. I do have my DVOM over there. So again, the relay terminal, fuse number 6, we have power at all times. This is power from the fusible link. It's connected directly to the battery, so you have power at all times on fuse number 6. Fuse number 6 feeds power to terminal number 3 of relay number 1. And then here are the connections for relay number 1. And remember how we were talking about how this layout on the manual, and you have to give it a 180. So we have terminals 2, 1, 3, 4. So if fuse number 6 feeds terminal number 3, then this terminal should have power, the one on the corner here. So yeah, let's see how it lights up. So we have power there. Now terminal number 4, this terminal, that would be key on power. So terminal number 4 of the relay, which is this one, and then this one of relay number 2, there is no power there right now, but if I turn the key on, it will have power. So let's give it a shot. Let's turn the key on. Okay, so I have the key on. So now in theory, terminal number 4 should have power. Yep, we have power right there. And then terminal number 4 of relay number 2 should also have power. Yep, right there. So, and that's terminal number 3 from fuse number 6. So right now we have power on terminal number 3, and then we have key on power on terminal number 4 of both the relay circuits. Okay. All right, let me turn the key back off. Okay, so now we get our meter and we check the camera back over here. Well, I'll just hold it actually. Okay, so our meter, we're just doing a continuity test. So we touch the terminals. Okay, so now we have continuity, able to measure continuity here. So we go to terminal number 1 of relay number 1. So terminal number 1 is this one here. I'll stick the probe in there, and then terminal number 1 of relay number 2 is right here, and we have continuity. And that's normal because when relay number 1 is activated, relay number 1, terminal number 1 sends power to relay number 2, terminal number 1. Okay, and then all right, so that pretty much covers terminal number 3 of relay number 1. Obviously that's full power at all times. Terminal number 4 is key on power. Terminal number 1 goes to terminal number 1 of relay number 2, and then terminal number 2 goes to the computer, and the computer grounds this guy in order to activate the relay. It grounds this guy when it grounds this terminal when you're cranking the engine only. Okay, on relay number 2, we have terminal number 1, which comes from relay number 1, and then we have terminal number 4, which gets key on power, and then terminal number 2 of relay number 2, this terminal here, this goes to ground. So whenever you have power on terminal number 4 from the ignition switch, this guy is terminal number 2 is grounded at all times, which means that the relay is going to be activated as soon as you turn the key on, and that's relay number 2. Terminal number 3 of relay number 2, that's the power out to the pump. Okay, so right now we're going to focus on terminal number 2 of this relay, this terminal here. Terminal number 2 should have continuity to ground, and I'll show you here with the meter. So we have terminal number 2 right there, and then a good ground location up here by the wipers. So we have one probe on terminal number 2 in there, and then the other one, basically any ground. You just go to battery negative like this, and you have continuity, because terminal number 2 of relay number 2, it just goes to ground at all times. Okay, now when you're checking a ground this way, I don't really like checking grounds this way, especially on a circuit that's a high current type circuit. Not very high current, but there are some amps going through there. The best way to check it is to actually put the circuit under some kind of load. So what I like to do is I like to get the test light, put it on battery positive, and then put it on terminal number 2, and then the test light lights up. The test light lights up. There's a little more current flow going through the test light than the continuity meter there, and you put the ground, you test. It's a better test for the ground, because if it's just barely touching ground with a little strand of wire, it's still going to show continuity, but it may not light up the test light. So it's a little bit better test to do it this way. The ultimate way to check a ground is with the circuit on and checking the voltage drop. That's the ultimate best way to check the ground, but we're not going to do that right now. All right guys, so we're pretty much done talking about the circuit here, as I showed you how these terminals are all connected and the way everything functions. Now if everything is okay up here and the fuel pump is still not coming on, then you have to go further into the circuit. You have to go further into the circuit, into the connector at the fuel pump, maybe the ground back there. So in order for that, you have to make access. Luckily Mitsubishi gave us this little access panel, and so you take this little cover off right here, and then you have another cover down here. I already have it loose here. There, and then you can see the pump right there. Oh, you can see the connector. It's kind of dark in there, but actually let me get a flashlight real quick. Okay, so you can see the pump connector. So I believe this right here, that connector that you see right there, this connector here, this is the connector at the pump F07 according to the wiring diagram. So if it comes down to it, then we would have to, I know it's a pain in the butt to get down here and everything else, but if it would come down to it, then we would have to go disconnect that and see if we're getting power to the terminal coming from terminal number 3 of relay number 2 down to this area here. And then the other side, the ground for the fuel pump, it's ground number 15, and it's somewhere underneath that panel right there according to the repair manual. We're not going to dig that up or anything else, but if push comes to shove, if you're in this situation where you have to diagnose this circuit, then you would have to go through all that stuff. But hopefully this information helped. Alright guys, so let's get these relays back on here. And hopefully we didn't mess anything up. Let's see here. So we have the fuse back in there. Yeah, one of the relays in here. And they are dummy proof. You can only put them in one way, because if they weren't, more than likely I would put them in the wrong way. Okay, so there's both relays are in there, fuse is there. Let me get my stuff out of the way. The covers are over there. So now cross our fingers and make sure it starts. bingo. It struggled a little bit because of the oh, you know what, I have the mass airflow sensor disconnected. Yep, I have everything disconnected, dang it. All right, anyway, you guys get the idea. So I'll put everything back together, and then we'll work on the no crank sensor signal, no start condition. So hopefully this helped, but stay tuned for the next part. All right, guys, so in this scenario we have a no start condition again, like earlier we were talking about with the fuel pump situation, but now we have another crank no start condition. If you can take a look, I already disabled it, and we have a no start condition. Okay, but we're at the point where you don't know if it's lack of fuel, lack of spark. We have no idea. So again, we have to use our method, divide and conquer. What does this engine need to start? You know, as I mentioned earlier, the engine only needs so many things to start. So something has to be missing. The cranking speed sounds like it's mechanically okay. It's got compression, otherwise it would be cranking really fast, as I mentioned. But one other trick up my sleeve here is to check for spark using a timing light. So I got my timing light right here. It's connected over there to one of the spark plug wires. It doesn't matter which one. I just need that high voltage detection from this timing light, and I just want to see if it flashes. If it flashes, guess what? We have spark. Okay, so let's crank it over. Okay, we got timing light is flashing, so we do have spark. Okay, so now if we do the carburetor spray thing that we tried earlier, it's probably going to start, because I just did this for illustration purposes. So let's go to the front here. Okay, so I got the timing light out of the way. I disconnected the timing light, and then now the reason why I wasn't starting is because I did the same thing as I did earlier. I removed the fuel pump fuse. So we're going to reconnect the fuse here. Now we're going to go back to the vehicle. It's going to start now because the fuel pump is now going to come on. There we go. We got a little bit of ticking noise. I'm not sure why. Okay. All right, I'm back, guys. So as you know, the Montero has a very sensitive lubrication system. If you, apparently right now, as I was cranking it to show you guys the no start condition and the timing light flashing, so all that time that I was cranking it, apparently the oil pump maybe lost prime, so it wouldn't pump enough oil to the top end. And also I think the way my driveway is, maybe that contributed. It's a little bit like it's on slope, and it started developing that ticking noise. Took it around the block one time and it went away. It happened to me a while back when I was doing the timing belt on it, but that's why I know that the Montero is very sensitive. But right now everything's back to normal. As you can see, it's quiet, it's normal. So earlier when I was showing you the timing light flashing, that's basically when you're not sure, okay, do we not have spark, do we not have fuel, what's going on, why isn't it starting? So a couple of quick things that you can do, again, like I showed you earlier, is spray some carburetor spray into the throttle body and just see if it starts. Okay, if it starts, then obviously you don't have to worry about spark because it started, and all it wanted was a little bit more fuel. If it doesn't start, then you do the timing light thing, check to see if the timing light flashes while cranking, and that tells you that there's high voltage going through these wires. Okay, so let's get on to checking out the crank sensor circuitry and stuff like that. Obviously, if you have a bad crank sensor, I'm going to show you right now in detail how to test all the circuit, all the wires and what each wire does and everything else. But also, when you have a bad crank sensor, you're going to have, I think it's a PO335 or crank sensor DTC. So crank sensor DTC, it's only letting you know that the computer did not receive the signal from the crank sensor. So, but yeah, obviously check the DTC and see which one you're getting, because there's some variations of the DTCs that might give you clues as to which direction to go. Okay, so let's get started with that information. Alright guys, so let's move on here to the crank sensor circuit. So the crank sensor, as I mentioned, this generates a square wave. It's basically what they call a Hall effect switch. It has a power supply right here on the red wire. It does have a ground wire that it goes through the computer to get ground, and then it has a signal wire. Now the signal wire basically gets grounded and ungrounded by the crank sensor as the trigger wheel goes by to let the computer know the position of the crankshaft. It does have a bias voltage, a 5-volt bias, as you can see right here. So if you unplug the sensor there and you check the voltage right there, you should have 5 volts. If you plug in the sensor, that may or may not be there depending on the position of the trigger wheel. But you definitely should always have a good battery voltage here and a ground there. And this ground is one of those grounds that you check the voltage drop on, and I'll demonstrate right now how to do that. So in this scenario with no start, no spark, this is one of the things that you have to check. My recommendation is with unplug, check all the voltage on these wires with the sensor unplugged, and then check the voltage with the sensor plugged in. Alright, so here's a crank sensor connector. It's very easy to get to. It's right up here. And as you can see, we do have the red wire right there. We have the blue with the red stripe, and then we have the sky blue wire right there. And right now with it unplugged, this is the side that goes to the sensor, this is the side that goes to the computer. Well, not all of it goes to the computer, just the ground. The blue and the blue with the red stripe go to the computer. The red one comes from the MFI relay. So in theory, based on our wiring diagram, with the key on, we should have 12 volts on the red wire. Let's just verify that real quick. I'll go ahead and turn the key on. Okay, so the red wire terminal is the one here on the bottom side. And when you check these terminals from this side, you don't want to jam your probe in there. If you can, with the tip of your probe, you can touch the metal, that's great. But don't try to stick it in there to widen the terminal, because then once you plug it in here, it's not going to make a good contact. So never do that. Right here I can see it, I can touch it, and it's not a big deal. I'm not really forcing it, I'm just touching the end of it. And then of course we have battery voltage, 11.9 volts. And also, as we mentioned before, the blue with the red stripe, which is the one on this side, that's the one that has the 5-volt bias coming from the computer. And let's just verify that right now real quick here. Yep, there it is, 5 volts. So that tells you that this circuit is getting power from the MFI relay on the red wire. That red wire from here to wherever it comes from, basically the relay over there, is okay. The 5 volts bias coming from the computer, we know that blue wire with the red stripe is okay as well. Now the ground, right now this ground wire, this one on this side, the sky blue one, it goes to the computer, through the computer, and then it grounds through one of the computer grounds. Now this circuit, there's no current flow going through it right now, so you can check the ohms from here to ground, and that'll give you an indication that it is connected to a ground at some point. Actually, let's do that right now. So I'm going to change my meter to continuity setting, which means that if I have continuity, then it's going to beep. Now the negative terminal is connected to the battery negative, and then I'm going to connect it to the ground wire here, but right now polarity doesn't really matter. Yeah, see, you hear a beep. So we know that that at least has continuity to ground. Okay, so now let's plug it in and see where we're at. We'll back probe the terminals. All right, so when you're checking the voltage on the crank sensor, it's probably better to use one of these adapters, so you can back probe the connector, and then you just go like this, back probe, and then you can feel when it touches the metal, because you're not going to be able to poke it any further. And then I'm touching the red, back probing the red wire. I have 14.1 volts, and I'm going to back probe the signal wire, which is the blue with a red stripe. And remember, this is a 5-volt square wave, so let's see what we get here. And we get 2.1 volts. 2.1 volts. And if you look at the little bar graph at the bottom, see how it's like moving back and forth. That's basically the signal going on off, on off, on off. It's averaging out at 2.1, 2.2 volts, but that little bar graph at the bottom is letting you know that this is something that's going on off, on off, on off. Okay, so now we're gonna back probe the sky blue wire, and this is the ground. There's a very small amount of current going through this ground, so we're going to check the voltage drop on this ground. We want to see no more than I would say no more than 20 millivolts on this ground. So let's check it out. And we have 30 millivolts. 30 millivolts. A little more than I like to see. But it's working fine, so I'm not gonna sweat it too much. All right, guys, just one more quick thing that I want to share with you guys relating to this circuit. So we talked about the crank sensor, we went over the circuitry and everything else, and the computer receives the RPM input from the crank sensor, but then the computer sends it out on terminal 87. Check it out. It sends it out and it goes to the AC system, the gauge, tachometer, and some other components. But it also goes to inspection connector, engine speed detection connector. What the hell is that? Okay, so it says it's B25X. So on this terminal, once we locate this terminal, I'll show you where it is. We can actually tap in there and check the RPM. However, you need a special meter for that. It's basically a square wave coming out of there. So your voltmeter is probably going to average out at a certain amount of voltage. You can probably do it with an LED test light, and it's going to blink on and off. Actually, I might try that. But it's a signal coming out of the computer, an RPM output signal. So you can actually check the RPMs there. You can do it. I did it. I have this old meter that I have had for years and years, and I can check the RPM. I just got to put it in the 6-cylinder scale right there, and then connect it to that connector, and I can get an RPM reading here. So this is kind of a little discovery that I did when I was checking this out. So let's go ahead and hook it up, and I'll show you. All right, so connector B25X is located right underneath this little cover. Remove the cover, and remember, we have fuel pump relay number 1, fuel pump relay number 2. B25X connector is right there. This little terminal on the corner here, there is a terminal right there. That is where you tap in to check the RPM. So I have my handy dandy meter here. Just put that right there. Put it on the 6-cylinder scale. Grab my probe, put one on the negative terminal like that, and then the other one we're gonna put it right in here like that. There's an old meter, so it broke. This thing broke, so it's not a big deal. Okay, so I'm gonna start the engine. Alright, so right now we are at about 1,000 RPMs, a little bit less than 1,000 RPMs. it's not 100% operating temperature yet. And the RPMs are, according to my meter, 820, 810. So it's this times 10. So times 10. So 840. And yeah, who would have thought, right? That this little connector you tap in to check the RPM. And you can probably buy one of these meters on Amazon if you really wanted to. You can, I guess the other thing is you can, when you have a no start condition, you can tap into it, crank it over, and see if you can read RPM. If you don't read RPM from this thing, then that means that the computer is not receiving an a signal from the crank sensor. So there you go. All right, guys, so this concludes the video for today. I really hope you enjoyed the video. I mean, some of the stuff is basic, I know. Immobilizer, no start when the transponder is not working, and you know, the relay stuff for the fuel pump. I mean, I think some people might find that useful, especially some of the newer people, new to electronics, new to cars, and also the crank sensor stuff. That information, you know, might be useful to somebody, especially that little connector with the RPM access. I thought that was pretty cool that Mitsubishi did that for us. So in conclusion, thank you everyone for watching. Thank you for sticking to the end if you did. And if you like the video, please share and like the video, and go ahead and subscribe if you haven't subscribed. So we will see you on the next one. Thank you.